Welcome. On this video, we'll be discussing the idea of applying inverse trig functions. So let's start by looking at this introduction question, which the idea is the following. Here we have a right triangle, and here we have a reference angle of theta. Can we write down some equations that we can use to solve for theta? Well, let's start by identifying the sides of this triangle in terms of reference angle theta. Well, in this case, P will represent the opposite, H will represent the hypotenuse, and A will represent the adjacent. Now, every time that we want to solve for theta, there must be some inverse function. So therefore, let's set up some ratios. Let's think about SOHCAHTOA since we're using a right triangle here. Well, I know that if I take the sine of this angle, that's opposite over hypotenuse. But we know what the opposite is. The opposite is P. So let's just rewrite this. So the sine of this angle, it will be P over H. What this is saying is that if I take the sine of an angle, that's equivalent to some ratio, which is P over H. So that implies that the theta, or that implies that the angle, it's equivalent to the inverse evaluated at P over H. But now let's try to understand what this is saying. This is saying that if I take the sine of an angle, that's equivalent to a ratio. So if I take the inverse sine of that ratio, that should give me my angle back. So in this case, we have properly defined one way that we can use to define theta. But we can define theta different ways. What's another way that we can define theta? Well, how about we take a look at another ratio? The cosine, it's equivalent to adjacent over the hypotenuse. But we know what the adjacent hypotenuse are. Adjacent is A, hypotenuse is H. So if the cosine of the theta, if a cosine of an angle is A over H, then definitely the angle is the inverse evaluated at that ratio, A over H. That's another way that we can define theta. Well, let's define theta a different way. Let's use tangent now. Let's never forget about tangent. So the tangent of the theta is opposite over adjacent, where opposite is P and adjacent is A. So therefore, if the tangent of the angle is P over A, then the angle is the inverse of P over A. So notice that what we have done, we have reviewed how to properly define theta in terms of inverse trig functions. But now let's actually use this information to solve certain situations. Oops, that's too much. All right, so let's take a look at example 1. Under example 1, we have the following. Let's solve the triangle for the angle theta. In other words, let's find the value of theta. So here we have our theta. And again, the first thing that you should always do is identify the givens. If this is theta, or my reference angle, then 9 represents my adjacent, and 12 represents my hypotenuse. So which of the trigonometric functions are we going to use? Well, we have adjacent, we have hypotenuse, so we definitely want to use cosine, because remember that cosine is equivalent to adjacent over hypotenuse. So let's just set it up. What we're saying here is that if I take the cosine of this angle, that's equivalent to my adjacent, which in this case is 9, over my hypotenuse, which in this case is 12. But we're not looking for just the cosine of the angle. We're looking for the value of the angle. So if we use what we just defined here, if this is how we have defined the cosine of theta under this ratio, then the angle is the inverse of cosine evaluated at that ratio. So that is saying that theta is equivalent to the inverse of cosine evaluated at 912. And this is something that we can use your graphing calculator to define. So where is it? So here it is. That's our graphing calculator. So let's just see what this value is. Let's just see what this value is. We have second cosine to get into the inverse cosine, 9 over 12. So what this is saying is that theta has a value, of 41.4 degrees. Now, one thing that I forgot to mention here is that when we're looking for inverse, if you want your result to be in degree, make sure that your calculator it's in degree mode. So we can press mode, notice that it's in degree mode, so we're okay. So make sure that it is under degree mode. But let's understand what this is saying. This is saying, look, is it true? And let's just test our result real quick. Let's just test our result real quick. Is it true that if I take the cosine of 41.4, is it true that that's equivalent to 912? Like, this is pretty much what we want to answer, because that's pretty much our result. So let's just test our result. Let's find the cosine of 41.2. I'm sorry, 41.4. That's 0.75. And 9 over 12. It's about 0.79. So now notice that this is true. So this is essentially what we're doing. We were finding an angle that will make this a true statement. And we just found it. It was 41.4. This looks like a 9, but it's 41. No, now this looks like a 9. Oh my god. 41.4. There it is. Let's solve for the second angle here. And again, how do you want to start problems of this form? Well, identify the givens. If this is my reference angle, then 6 is my opposite, and 10 is my hypotenuse. So let's think about it. Which of the trigonometric functions uses opposite and hypotenuse? Yep, you're right. It is sine, because remember that sine is opposite over hypotenuse. And remember that you can remember all this using SOHCAHTOA. So if this is true, if the sine is opposite over hypotenuse, let's just set it up. So what we're saying here is that if I take the sine of my angle, that's equivalent to 6 over 10. And if this is true, then theta is the inverse of sine evaluated as 6 over 10. Well, let's find what that is. Take the second sine 6 over 10. So now we got the theta. It's equivalent to 36. 0.8 degrees. And again, let's just test our result. Let's see if this is true, because you always want to make sure that what you write down here is true. So let's just test it. Let's see if this is true. Now, is it true that if I take the sine of 36.8, is it true that that's equivalent to 6 over 10? I don't know. Let's find out. Let's take the sine of 36.8. That's 0.59. And 6 over 10. Yeah, pretty close. 0.599 is close to 0.6, so we're just going to say it's true because it's an approximation. So now notice that all we were doing is we were finding an angle. We were finding an angle that if I take the sine of that angle is equivalent to 610. So we were just looking for an angle that will make this a true statement, and we have found it here. It was 36.8 in example B, and it was 41.4 in example A. So notice that this is very important. The idea of understanding that we use inverse functions to define angles. So now let's take a look at something a little more complicated, which is the idea of composition. And composition can be a little bit more tricky because we have to remember the different restrictions that we discussed in class. We have to remember those restrictions. So let's just recall that for sine, in order for the inverse to be a function, then we have to restrict the sign. We have to restrict the domain to be between negative pi over 2 and positive pi over 2. Notice that this is a restriction that we discussed in class. So if we want to use the inverse of sine, we have to make sure that our values are between negative pi over 2 and pi over 2. So what I'm trying to say here is that notice that here you might be tempted to just cancel sine with the sine due to the cancellation law, and our result is to be pi over 3. But in order for that to happen, you have to make sure that this angle is between negative pi over 2 and positive pi over 2. So let's just visualize this. Let's just visualize this. So this is the only values that we're allowed to use. Here is negative pi over 2, and here is positive pi over 2. So we're only allowed to use values between negative pi over 2 and positive pi over 2. So it's pi over 3 between those values? Well, definitely is, because pi over 3 is 60 degrees. Pi over 3 is 60. And notice that pi over 3 is definitely in the restriction. It's definitely a value that is between the restrictions that we defined previously in class. So since my value is between that restriction, then therefore we can apply the cancellation laws. And what the cancellation law is that if you have a sine, inverse of a sine, and the inverse of the sine is between this domain, then therefore, boom, they're gone. Then my conclusion is that the composition is equivalent to pi over 3. But again, don't always cancel out right away. You have to make sure that at least when it comes to sine, it is between pi over 2 and negative pi over 3. Well, let's take a look at example B, and it's going to become a little more clear as to why is it that we have to make sure that that is true. And what do we do whenever it's not on it? Because if we take a look at pi over 2, you might be tempted to just apply the cancellation law. Sine inverse with sine, they cancel out. So my result is 2 pi over 3. But is 2 pi over 3 in the restriction that we have for sine? Well, let's find out. Let's do a visual representation of what's going on here. So let's think about this. Again, we're only allowed to use, if we want to apply the cancellation law, then my angle should be between negative pi over 2 and positive pi over 2, because that's the restriction that we apply for sine. But one thing that you might notice is this. One thing that you might notice is that, let me just change this to blue. If we graph down 2 pi over 3, you will see that that's 120 degrees. With 120 degrees is definitely, let me just put it here. 2 pi over 3. 120 degrees is definitely not in this restricted domain. So does that mean that we can use the cancellation laws? Yes and no. The way that it's written down, no, because the angle is definitely not between pi over 2 and negative pi over 2. But notice what we're going to be doing now in order to fix that problem. Well, notice that if we take a look at a unit circle, exactly at 120 degrees, we have the coordinate point negative 1/2, comma, pi over 3. I'm sorry, square root of 3 over 2. But also, notice that at exactly pi over 3, let's just put it here. At exactly pi over 3, we have the coordinate point positive 1/2 square root of 3 over 2. So now let's pause here for a second because right now it's not so much that we're just looking at the angle, but we're concentrating on the whole thing. Notice that the sine of those two angles are essentially the same. Notice that the sine of 2 pi over 3 is equivalent to the sine of pi over 3. Because recall, sine are the y values in my unit circle. So that if I take a look at the y value, it's square root of 3 over 2. And if I take a look at my y value, that's square root of 3 over 2. So we can say that they're essentially the same. So if they're essentially the same, then we can just rewrite our function then. Because now instead of seeing our function this way, I can just say, look, if they are the same value, then I can just substitute it. But what's the benefit of writing it this way? We just show that they're equivalent, so therefore I can write it. But notice that if I write it this way, pi over 3, it's in my restricted domain. So therefore, since pi over 3, it's in my restricted domain, then we can apply the cancellation laws. And that's equivalent to pi over 3. So in conclusion, the sine of -1, or the inverse sine of 2 pi over 3, this is not equivalent to 2 pi over 3, but this is just equivalent to pi over 3. And the reason why this is different is because of, you just got to be careful with this restriction. Like, the restriction has to be true if we want to apply the cancellation law. So that might be a little bit tricky, but just remember that if we want to apply the cancellation laws, the inside of the sign, it should be between negative pi over 2 to positive pi over 2. For cosine, it must be between 0 to pi. And for tangent, it is negative pi over 2 all the way to positive pi over 2. Okay, so let's take a look at one more composition question. Let's take a look at one more composition question now. Take a look at example 3 now. Let's take a look at example 3. Let's take a look at example 3 now. Okay, first things first, can I apply the cancellation laws? No, you can't, because we have different functions. Okay, so the cancellation law cannot be applicable. So what can we do? Well, first, it's 13 pi over 6 on my restricted domain. And remember that for cosine, oh no, hold on. We can just evaluate this as it is. We don't have to really take a look too much at the restrictions yet. So let's try to simplify this. But notice that 13 pi over 6, this is equivalent to 390 degrees. So let's just rewrite this. So 390 degrees, what this is saying is that you can go 360 degrees plus 30 more, and you will get 390 degrees. So pretty much what we can do is just say, well, instead of looking at the cosine of 390 degrees, I can just rewrite this and find out that this is equivalent to the cosine of 30 degrees. And now let's just evaluate this by piece. So let's evaluate the inside. Let's evaluate the inside. What that is saying is, like, what is the cosine of 30 degrees? And if you take a look at your unit circle, you will see that the cosine of 30 degrees is equivalent to square root of 3 over 2. Cosine of 30 degrees is square root of 3 over 2. And now notice that we have here. What we have here is the following. We're saying, look, that's the inverse function. So I know that my result must be of a degree, or it must be some kind of an angle. So what angle can we use such that if I take the sine of that angle, it's equivalent to pi over 3? Remember your unit circle. We have square root of 3 over 2, comma 1 half. We have square root of 2 over 2, comma square root of 2 over 2. And we have 1 half, comma square root of 3 over 2. And notice at 30 degrees, this is pi over 6. And notice at 45 degrees, that's pi over 4. And 60 degrees, that's pi over 3. So now we're literally just saying, look, where in my unit circle is the sign equivalent to square root of 3 over 2? Well, notice that that's essentially here. That's essentially here at pi over 3. The sign of pi over 3 is square root of 3 over 2. Last thing is that in my restriction, well, remember that for sine, we're restricted between negative pi over 2 and positive pi over 2. So yes, it is in my restriction, and that's the value that we're looking for. So what it's saying is that now the angle is just equivalent to pi over 3. Because notice if I take the sine of the angle of pi over 3, we have a value of square root of 3 over 2. Okay, so I think I'm just going to go as far as example A. Hopefully this is helpful. And if you have any questions, you can always ask me in class.